So I am starting jet transformation. Jet transformation is discrete transformation, and I believe you know the basic of Laplace transformation. So first I would like to convert the Laplace transformation into jet transformation, and I believe that you will enjoy this. So jet transformation. Okay, now first I want to very specifically ask a question to you, whether you can distinguish del T and del N. Do you know the difference between del T and del N? What is del T? I believe so many of you know. And what is del N? So you can say that, sir, del T is the impulse function corresponds to the continuous time domain, and del N is the impulse function corresponds to the discrete time domain. But this is not true. This is not utterly true. Why? Just let me clarify del T and del N. So I am writing del T. What is the definition of del T? Del T is equal to, follow me, del T is equal to infinite when T is equal to 0, and is equal to 0 when T is not equal to 0. I believe all of you know this. Along with this is not the sufficient definition of del T. Why? Because infinite is there and infinite cannot be well clarified. Infinite can be theoretically pursued. So for this time being, what we should write along with this one, that is this one, that is, I believe you know, that minus infinite to plus infinite del T dt is equal to 1. So this is the complete definition of del T. Okay. But whenever I would like to ask you about the del N, so what is the definition of del N? What is the definition of del N? Follow me. Del N is equal to 1 when N is equal to 0, and is equal to 0 when N is not equal to 0. I believe you can wisely distinguish del T and del N. So now the question is, N is what? N is the sequence. Okay. Then when the sequences come, the sequences come after duration T, capital T. What is capital T? Capital T is the sampling duration. Now you follow something, just I am clearing. So for this timing, if I ask you that, point number 2, if I ask you that what is the Laplace transformation of del T, then you can wisely say that this is nothing but 1. Now very wisely I am asking you that you have understood what is del N. Now if I ask you what is the Laplace transformation of del N, what is this? Then you are confused, because for this timing if you consider that del N is 1, then it must be 1 by S, but that is not true, because del N is not utterly 1. Del N is 1 only when N is equal to 0. So you very wisely should understand the difference between del T and del N. Okay. Now I am coming to discuss about the impulse train. So what is the basics of the impulse train? Point number 3. So impulse train means what? That is, the impulses are generated. This like this. So and now you follow. First impulse is generating at t is equal to 0, and which is marked as set T. Follow me. This is our time axis. This is our 0 point, time 0. Now the first impulse is generated, and this is del T, right? The second impulse, in causal sense, that is, I am considering that time is positive. So the second impulse is generated where? At t is equal to t, and this very impulse is said as del T minus t. Okay. So impulse train. First let me draw the impulse train. Okay. First let me draw the impulse train. So the impulse train is like this. Follow me. This one. This one. This one. This one. This one. And if you consider the non-causal part, that is negative t part, the graph is associated with these impulses also. Okay. Now a total set of functions is called del dt. Okay, total set of functions. Follow me. This one is not del t. Now, for this timing, I am very specifically marking the individual functions. So this is 0, this is t, this is 2t, this is 3t, 4t as well, and this is minus t, minus 2t, minus 3t as well. Now the first one is what? The first one is del t. This is what? This is the shifted version of del t, that is del t minus t. This is del t minus 2t. This is del t minus 3t as well. Okay, and in this part what should be written? So this is del t plus t, this is del t plus 2t, and so on. Now on the basis of this very expression, if I simply ask you what is del tt, del tt is what? Look, del tt is not a single function. This is a composition of functions. Which functions? The functions are the impulse functions. So this is nothing but summation of all of the functions. So what I should write? I should write this is equal to del t minus nt. Am I clear? So n is equal to minus infinite to plus infinite, being n as integer. N belongs to integer. Follow me. N belongs to integer. So this is the expression of impulse train. Am I clear? Now, with the help of this one, what we are going to do, just you follow. I am clearing. Now say, I am asking you to develop the Laplace transformation of impulse train. Say we are having point number 4. Let we are having an expression as say xt is equal to del dt. Am I clear? Now I am asking you to determine xs. What is xs? Follow me. What is xs? So xs is Laplace of summation n is equal to minus infinite to plus infinite del t minus nt, where n belongs to I, integer. Now the question is, for this timing, if you would like to determine Laplace transformation directly, you obviously would face some problem. But if you individually can think, then no problem would be there. How? Just you follow me. I am not clearing, but along with this one I am drawing. So you follow that the Laplace transformation of this one, follow me, this is del t, and the corresponding Laplace transformation is 1. This is, follow me, this is del t minus t. So what is the Laplace transformation of this? Follow me, follow. Shifted version of this one, so e to the power minus st of 1. So I am not writing 1. Okay, and this is say del t minus 2t. So the Laplace function of this one is what? E to the power minus st, sorry, e to the power minus 2st, and interestingly you follow that this could be written as e to the power minus st squared. Am I clear? So 0 corresponds to e to the power minus st to the power 0, t corresponds to e to the power minus st equal to the power 1, 2t corresponds to e to the power minus st square as well. Now you come to this side. This is a very important point whenever you are coming this side. Now this is del t minus t, sorry, t plus t, and I am asking you, what is the Laplace transformation of this one? Can you understand? I am asking you what is the Laplace transformation of this one. So many of you are confused, and you can say that, sir, this is quite obvious that following this very side, whatever you wrote, that is e to the power minus st, we obviously should write e to the power plus st. But the question is, normally, whatever you know, that the Laplace transformation starts from 0. Can you understand? Normal Laplace transformation starts from 0. So whenever you think this one, this is before 0. Can you understand? This is before 0, this is minus t. So normally if I ask you what is the Laplace transformation of this, this must not be true. This must be what? 0. Why? Because before 0, whatever functions, whatever impulses or functions are existed there, we must consider that as 0, because Laplace transformation starts from 0, but the question is there. That is what Laplace transformation? So normally we know single-sided Laplace transformation, but practically we must know the double-sided Laplace transformation. So I am simply writing. So this is true. Okay. Following what? following bilateral Laplace transformation. So we have to follow bilateral Laplace transformation. I believe you are understanding. Otherwise, I am writing. So follow normal Laplace transformation follows single side Laplace transformation, and we write xs is equal to what? Integration 0 to infinite xt. Follow me. Xt dot e to the power minus st dt. Now, if we follow this one, then we must not consider the function which is before 0. Am I clear? And for that, we cannot write e to the power plus st. But, and this is what, as I told, this is unilateral Laplace transformation. Unilateral Laplace transformation. Now, despite of this one, another Laplace transformation is there, which should be followed here. That is minus infinite to plus infinite xt dot e to the power minus st dt. This is called bilateral Laplace transformation. Bilateral. And very important point, I am bilateral. I am telling, I'll be using these terms afterwards, but I believe that so many of you are familiar with that. That is, whenever we will be using bilateral Laplace transformation, then one very specific term will come, that is called region of convergence, that is ROC. So you must be sincere to follow ROC. I'll come. So I am writing bilateral Laplace transformation. Am I clear? So following this one, we must not follow this one, but this one, the expression of total what, that is impulse train could be written as what? I am clearing. So expression of Laplace transformation of impulse train could be written as what? You follow, very simple. So what I am doing, I am writing here, Laplace of del t is equal. First I am writing that plus e to the power st, follow me, e to the power st cube, e to the power st square, e to the power st, then 1 means e to the power st to the power 0, so I am writing 1, plus e to the power st, okay, e to the power st whole to the power minus 1, e to the power st whole to the power minus 2 as well. Can you understand? And this very point corresponds to n is equal to 0. So that is marked by arrow. So I am marking this as arrow. This very value corresponds to what? N is equal to 0. So we are having a complete series. So accommodating the total series, what we can write? This could be written as, follow me, n is equal to minus infinite to plus infinite e to the power st whole to the power n. Can you understand? So this is the Laplace transformation of impulse train. Now, after learning this one, follow me. After learning this one, what I am doing you for? I am clearing. So this is the Laplace transformation of impulse train. Now point number 4. Now say I am giving you an expression of xn. Follow me. Xn is equal to, say, 4, 6, 2, 1, 5. Okay? This is called finite response. Why? Because the boundaries are finite. The xn existed from, this is what? N is equal to minus 2 to n is equal to plus 2. N is equal to, that is sequence, minus 2 sequence, and this is plus 2 sequence. I believe you can understand. So this is the expression of xn. Am I clear? Now, if I ask you to understand what is this in your normal continuous time domain expression, then you must say that, sir, this should be like this. If I do have time axis as t, the corresponding values like this. Follow me. Okay, so this is 0, this is t, this is 2t, this is minus t, and this is minus 2t, and the corresponding values are like this, that is that is say 2, this is 2, this is 1, this is 5, this is 6, and this is what? 4. Can you understand? So the values are like this. Okay, and this is what? If I accommodate all of the functions, then this should be what? Now follow, you have to know the art of expression. So in this case, I have marked this one as the domain. So this is our domain. Follow me. This is our domain. So now, if you express this one as xn, you must be wrong. Why? Because function of what? Function of domain. Am I clear? So this is the function of domain. So domain is t. So this must be written as xt. But in this case, what is written? Xn. So a problem is there. So for this timing, what I am writing this is as xt. Am I clear? But whenever I am writing this, I have to remember that this very xt is not continuous. Am I clear? The xt's existed when t is equal to nt, when n is integer. Nt, t means capital T. Am I clear? So this is xt, but in discrete manner, and that's why this function is called discrete function, right? So now I am asking you, can you relate xt and xn? This is xt. Whatever I have drawn. Now you may follow this one, that is despite of t, you can write n, and then you can write 0, 1, 2, 3 as per sequence, and you could write xn. But for this timing, you follow whatever I have written. That is the domain axis is written as t. Now I am asking that can you relate this very xt and this very xn? Follow me. Can you relate? Then you must say that, sir, we can relate. How this will be related? Follow me. This is associated with, this is associated with an impulse. This is associated with an impulse. This is another as well. So following that, what we can do? I am clearing. So now what we can do? We can write xt as, follow me. We can write xt as, follow, 2 dot del t plus 1 dot del t minus t plus 5 dot del t minus 2t, and you come this side, 6 dot del t plus t, capital T, and 4 dot del t plus 2t. Can you understand? Now this can be written as xt. Am I clear? This can be written as xt. Now what is the problem? Problem is, if you are not well understand, if you cannot well understand del t, then you cannot understand this one. First you have to remember that is del 0, follow me, del 0 with integrated version as 1. Del 0 corresponds to 1 in integrated version. And when del something else than 0, not equal to 0, then what? 0. Now with this expression, if I ask you that what is the value of, say, xt when t is equal to 2t, then you follow, this is not non-zero term, this is non-zero term, this is non-zero term, this is non-zero term. So all the terms are vanished. Only this term would be 1. Follow me? 1. And so you finally get 5. Say, can you understand? So this is non-zero term, this part, which is confined into the brackets. So this part is non-zero, this part is non-zero. So all the terms are becoming 0, because 4 into 0, 6 into 0, 2 into 0 as well. So this is equal to 5. Can you understand? Now if I ask you xt when t is equal to minus t, follow me, then you put this value. So this is non-zero, so vanished. This is non-zero, vanished. This is non-zero, vanished. This is non-zero, vanished. Only this very term would be there. Del 0, 1, so 6. So by this way we can express. Can you understand? So what we are learning in this expression, that is the xn. That is the expression of xn can be written in terms of this one. Am I clear? Now I am asking you to follow Laplace transformation of xt. So you follow the Laplace transformation of xt. So what is xs? In this case I am writing xs. So if I ask you to follow the right hand side, what should be written? Follow me. This should be 4 dot e to the power 2st plus 6 dot e to the power st plus 2 plus 1 dot e to the power minus st plus 5 dot e to the power minus 2st. Can you understand? Now in our normal practice, the terms which come very frequent, we name the term. So in this case, what we are following, that the term e to the power st comes frequently. E to the power st. This is e to the power st to the power 0. This is e to the power st whole square. These two coming here. So e to the power st frequently comes, and that's why what we are doing right now, we are naming e to the power st. Am I clear? So we are naming e to the power st. Clearly? So we are naming e to the power st as what you know. We are naming e to the power st as what? E to the power st as z. Am I clear? So as this term is coming frequently in this expression, and that's why we are writing the expression as, e to the power st as z. Am I clear? Now I am following another problem. I am clearing. Now I am following another problem. Say problem number 5. Say you are given xn is equal to, follow me. You are given xn is equal to, say 1, 5, 6, 2, 9, 4. Okay, and the arrow is here. And then if I ask you that what is xs, so whatever you have learned, on the basis of that, what you should write, that is 1 dot e to the power st, follow me, plus 5 dot e to the power st whole to the power 0, plus 6 dot e to the power st whole to the power minus 1, can you understand? Plus 2 dot e to the power st whole to the power minus 2, you have already learned. 9 dot e to the power st whole to the power minus 3, and 4 dot e to the power st whole to the power minus 4. Now the question is, just I have taught that e to the power st is marked as j. Am I clear? So the right hand side, follow me. The right hand side, in this case you have to very specifically know about the domain. So in this case, what is the variable quantity in this case? S. Why? Because t cannot be varied. T is the, what is t? T is the sampling period. That is not varying. So what could be varied? We do not know whether S is varying or not. But in this case, we are considering that S could be varied, and that's why the left hand side is marked as S, because in the right hand side the expression is written in terms of S. Now what I am doing, I am writing this is as what? You follow? 1 dot j plus 5. You may or may not write j to the power 0. I am leaving. So this is 6 dot j to the power minus 1. Then 2 dot j to the power minus 2. 9 dot j to the power minus 3, and finally 4 dot j to the power minus 4. Am I clear? So what you have done, you have converted e to the power st in terms of j. So right hand side has been a function of j. So why you should write left hand side as a function of s? Because s has been converted, s has been modified with e and capital T. So better the right hand side should be written in terms of z, and that's why this is written as xz. Am I clear? So this is becoming the z transform of xn. So what we should write? First of all, whenever you should think, following what method, following what approach you should think, that whenever you are thinking about the z transformation, you should think like this. Follow me. xs is converted into xz. So we should think how. I am explaining. First, you are given a discrete data set. So whenever you are having this very discrete data xn, then you have to think its corresponding continuous data as xt. Sorry, not continuous but time domain data as xt. Then you have to follow what you could have this very expression incorporating what? Incorporating the impulse train. I already told. So from here to here, what you have to incorporate? Impulse train. Now whenever xt is there, by performing Laplace transformation, you can obtain xs. And then what you are doing? Then e to the power st is converted into z. And finally you are writing xs equivalent to xz. So this is the fundamental realization of z transformation, right? So from xn to xz we can convert, that is learned here, and this is the essence of z transformation, in which we are just simply converting the discrete transformation and basically the Laplace transformation into a discrete format. Okay, so in our next video what we will be doing, we will be very wisely understanding what is e to the power st. Okay, and I'll be showing you some very simple manners by which you can easily perform Laplace transformation, I mean jet transformation, right?